Good afternoon, students. I am Nilendu. I actually teach physics in class 11-12 level, both in ISC and CBSE board, as well as West Bengal board. Today I am discussing about very important topic, important chapter in class 11 level, that is projectile motion. Oblique projectile, ground to ground projectile. Ground to ground projectile means when a body is projected. What is projectile motion? When a body is projected vertically upwards, anything that is projected is called projectile motion. So, when a body is thrown vertically upwards, that is, it is making some angle. Suppose it is a ground and it is going vertically upwards. After some time, it comes back to the initial point. That is, you are making some angle 90 degree with the ground and is coming back to initial point after some time. In all the projectile motion, we will take air distance is 0. That is why time of ascent, that is when it is going up, that time, and time of descent, that is when it is going down, that is when it is coming back to initial point. Both the times are equal. Suppose a body is projected upward and is going some height in 2 seconds. In absence of air, it will come back to its initial point again in 2 seconds. But when it is thrown at an angle some, suppose a body is ground, it is thrown in this direction. So what will happen? After some time, it covers some horizontal distance. It will be type of curved path and it travels horizontal distance, and after some time it reaches to the ground at the end part. When if it is thrown from a point O, then after some time, suppose it comes back to another point B on the ground. To understand clearly the projectile motion, you should have a clear idea about vector analysis. Not vector analysis, actually vector conception. For this, you got to know about rectangular resolution of vector. That is resolution of vector. What is that? I am showing you in brief. Suppose it's a vector. It is inclined at an angle theta with horizontal point, with some horizontal. Suppose this vector is P. Then one component, if it is resolved into two components, then one component should be in this direction and other component should be perpendicular to this direction. That is, if you want to resolve this vector P, then it should be resolved into two components. One component is horizontal and the other component is vertical, and this vector should be along the diagonal of the rectangle or square that I have drawn here. If this component is x and if this component is y, because it's on x axis and it's on y axis, then x should be p cos theta and y should be p sin theta. That is the angle. The component with which angle is drawn, it should be cos component, and another thing will be sin component. So, when a body is projected with some velocity, you know velocity is a vector quantity, then we can easily resolve it into two vertical components. If the velocity is v, then one component should be v cos theta and another should be v sin theta. I am showing you. One more important thing you have to know: perpendicular to any vector, no component can exist. Showing you. Acceleration due to gravity, you know very well. When a body is coming down towards earth, due to force of gravity, then the body is coming to earth with some acceleration. It's called acceleration due to gravity, and it is denoted by g. Magnitude of g 10 meter per second square or 9.8 meter per second square. In your numericals, they will provide the value. If they don't providing any value, then you have to take 9.8 meter per second square. That is equal to g. And if they provide g equal to 10 meters per second square, then you can easily apply this value. Anyway, that is G is acting vertically, maybe upwards, maybe downwards, and you know G is acceleration due to gravity, so it's a vector quantity. So if you want to make a component perpendicular to G, that is in this direction, that means this angle that I have taken here, theta, that theta equals to 90 degree here. So perpendicular to this component, we can take magnitude of G is here. It can be written in here also. It is also theta equals to 90 degree. Theta equals to 90 degree here also. So perpendicular to this component, we can take component of G equal to G cos 90 equal to 0. Because the angle theta is giving horizontal component, cos component, that is why we have taken here G cos 90. Here we have taken x equal to p cos theta. So here x equals to p, but means G cos theta means cos 90, 0. So perpendicular to any vector, no component can exist. Suppose the body is projected horizontally in this direction. So its vertical component Vy should be V cos 90 equal to 0. It may be in this direction also, Vy, that is also 0. So most important topic in projectile motion, that perpendicular to any vector, no component can exist. Now I am giving a diagram here, I am drawing here, just wait. Look, y-axis, x-axis, point is O, origin. I am throwing a body and it is traveling a curve. Okay, so when you want to give a velocity at the point O, because you have to give some velocity, otherwise it can't travel in this way. If theta goes to 90 degree here, then it will go upward and it will come back to initial point. But here theta is not 90 degree. I am giving the theta, that theta is something less than 90 degree, but theta should be greater than 0 degree. So if this velocity is u, then we can take the component, and you know very well, to any curve, direction of velocity is always along the tangent, drawn at the point of projection. O is the point of projection. So if we want to have some two components, then we have x component ux equals to u cos theta, and y component we will take u sin theta, y component we will take uy, that is u sin theta. It travels along a curve OAB and reaches down after some time at point B. This distance O2B, we can say it is x-axis displacement, that is we can say in projectile motion it is say range R. It can be said also horizontal range, same thing. And it is the maximum height, you see, H. It is going upward, upward, upward. At this direction, the velocity component is here. Velocity is here in this direction, not component, velocity is here. So at the highest point A, velocity component equals to V cos 90 equal to 0. That's what I told you earlier. This angle is 90 degree. So at the highest point A, vertical component of velocity equal to V cos 90 equal to 0. With the increase of the distance, with the increase of the height basically, with the increase of the height, actually angle is decreasing. Look here, here angle is theta. Whatever may be the value of it, maybe 60 degree, maybe 45 degree, maybe 50 degree, whatever. But if we draw a tangent here, you see angle is decreasing. Slope is decreasing, so angle is decreasing. With the decrease of the angle, sin theta also decreases. At this point, theta equals to vertically, that is this angle here equals to 0 degree. This angle here, it is suppose alpha, and here alpha you see less than theta. But when you reach at the point A, that alpha becomes 0, alpha becomes 0 means sin component u sine component, u sine theta, that component equal to u sine 0, 0. That is why By is coming 0. We have taken here horizontal component B, this angle is 90, so horizontal component actually B cos 90 is 0. Basically, at the highest point, in any way we can say vertical component of velocity is 0. Now we can take a point here also P. Coordinate of this point we can take xy, so we draw a perpendicular here. That point we have taken Q. So when we want to find some equation of projectile motion, then we have to take the point P. We have taken to travel the point O to P, time taken is t. Time taken is t. So when we reach at the point P, then what will be the value of this OQ? If it is 4, suppose x equals to 4, y equals to 2. Then obviously in graph OQ equals to 4 and PQ equals to 2. But I will take OQ equals to not 4, OQ equals to I will take x, because we don't take 4 here. We can't take 4 or 2 here because it is precisely, it will be a fixed point, but it is not there. It is not that. Maybe that point is here also P. Maybe that point is here also P. So we take an arbitrary point xy. Arbitrary Cartesian coordinate is xy. If we want to find out x, we will say x equals to OQ equals to ax. OQ equals to actually ax, and that is equals to u x into t. You don't take any g along OQ because g is acting vertically. So component of g along x axis will be 0, that I have discussed earlier. So that g part will not be here. Basically distance formula is equals to ut plus half gt square or ut minus half gt square. A square, but here a equals to g, so we will take a equals to g or half g square or half at square. But here we can't take any g because the horizontal component of g along x axis is 0. So we will take only s equals to ut. Here u equals to actually ux, t to t. So it is coming uxt, that is u cos theta into t. So x equals to, we have x equals to u cos theta into t. So what will be the value of t here? T equals to x by u cos theta. So here I am writing. So t equals to x by u cos theta. We have got t equals to x by u cos theta. Now we have to find out y. What will be that? Y equals to vertical component, that is u sine theta ut plus half gt square. We will take here uyt minus half gt square. Because whenever you do any calculation along x axis, you take ux. Whenever you are doing any calculation along y axis, you take uy. So it should be uyt minus half gt square. It is thrown against gravity, that is why minus half gt square. So y equals to uy means u sine theta. So it is coming u sine theta t minus half gt square. Finally, it is coming y equals to u sine theta t. We have found out x by u cos theta minus half g x by u cos theta square. U cancel out, so y equals to actually tan theta into x minus gx square 2u square, because it's square form, so 2u square cos square theta. This is the parabolic equation. Parabolic equation actually y equals to ax plus bx square or x minus bx square you can write. So just compare here y, x, so tan theta equals to a, x square, so b equals to g by 2u square cos square theta. So the path of projectile is parabola.